It's another video about this axial flux alternator I built. It's a little one, really designed for education. I'll be driving it with this small 3-foot-ish diameter rotor that we made. The alternator has 4-inch discs on a 1/2-inch shaft, and the magnets, it's got 8 magnets per rotor. They're 1-inch diameter, 1/4 inch thick, and I've just glued them on here. To run at real high RPM, I'd like to put some kind of band or maybe some sort of housing around this to keep the magnets from flying out, but so far it's been all right. The stator, I just glued coils to a piece of plexiglass. This is 100 thousandths of an inch thick. The coils are 3/8 inch thick. We wound them with 22 gauge wire. There's 170 turns per coil. And the way we wound these on a little spool. Hold on, I'll get the spool. This is the spool I used. Just made it up out of plywood, put it on a 3/8 bolt, and stacked some washers in there. On this one, I wound the coils a little extra thick, and I smashed them down. I clamped them down to 3/8. So to do that, I wound the coils, took them out, put them on put some super glue on a piece of wax paper, put the coil on it, put more super glue on top of the coil, folded the wax paper over it, and smashed them down to exactly 3/8 inch thick. I had some concern that smashing them so hard would compromise the insulation in the wire and cause a short, but that hasn't happened, so it seems to work. I made a lot of coils and I never had a short yet. So there's eight magnets per coil. There's 6 coils, and it's wired in 3-phase. 3-phase star connection on this. The axial flux design, this is wonderful because there's almost no friction. It's pretty effective, and I can demonstrate that here. I'll just short one phase, and it's pretty dramatic, at least this alternator. This alternator has a lot of magnetic material. You could probably get away with half, or I could be using ferrite magnets instead of neodymium. Maybe I'll do it right here. Does that? No. I can do it this way. You'll see what happens when I short this out. It stops immediately. So it's pretty a pretty stiff alternator. When I test this with the voltmeter, roughly I seem to be getting about 0.6 volts per RPM. So that would be about 6 volts AC at 100 RPM. I think. I haven't really tested this well yet, and that'll be the second half of this video. We'll test the alternator. Other information I have on this alternator is stator resistance. There are 2 ways to measure stator resistance. One, I can just weigh the coil, or I can weigh the whole stator and look at a wire gauge chart and find out the weight of this wire. By the weight, I'll know how many feet of wire are in it, and I can know the resistance of the stator. And alternatively, I can just use my ohm meter, and this does an okay job. So there it's showing around 3.6, so about 3.3 ohm I'm coming up with, which is pretty low resistance for a machine like this, unless it's very high voltage. A 3-foot diameter wind turbine is going to want to be running really high RPM, so this is going to be really high voltage, really low resistance. It's going to be too efficient for a rotor this size unless we do something weird like MPPT. guarantee, but it's just for education, and I really don't mind that the alternator is much too efficient for this application. What else about the alternator? I guess that's about it. We'll test it, and I think I'll put it on the milling machine and run it at various RPM, and we'll do some load testing on it and get a power curve.